Okay, what we're going to do in this lesson is look at three special parallelograms. Those three are a rectangle, a rhombus, and a square. And so we're going to use the definitions of those three figures in combination with theorems 5.12, 13, and 14. And if you look at the second page of your note, you will find a small flow chart which shows parallelogram, rectangle, rhombus, and square. And what we'll do is use these diagrams and make a series of markings based on the definitions and the theorems on the previous page. And so I'll use the diagrams and the markings on this page to explain the definitions and the theorems contained on the previous page. And so what we'll do is we'll start off with our marking our parallelogram. And so we have on the parallelogram, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. And what we're able to do is use this information, of course, to in combination with congruency of triangles to then prove that a parallelogram, in addition to having both pairs of opposite sides parallel, has both pairs of opposite sides congruent, both pairs of opposite angles congruent, and it also has diagonals that bisect. Okay, and so what we're going to do now is use the characteristics of a parallelogram, or rather the markings of a parallelogram, and we're going to mark our rectangle diagram. And so by definition, a rectangle is a quadrilateral with four congruent angles, or four 90-degree angles. And so this means that a rectangle is a parallelogram because it adheres, or both pairs of opposite angles in a rectangle are congruent. This means it is a parallelogram as well. And so in addition to having all four angles congruent, the rectangle would also share the properties of a parallelogram. And so both pairs of opposite sides would be parallel, both pairs of opposite sides would be congruent. The diagonals would, of course, bisect as well. And then if we go back and have a quick look at our theorem 512, in addition to the definition of a rectangle, which is a quadrilateral with four right angles, we also have the rectangle diagonal theorem, which says that the diagonals of a rectangle are congruent. And so, excuse me, in addition to the diagonals bisecting, if KM and NL are congruent in length, then what we actually end up with is four congruent segments, KO, OM, LO, and ON. Okay, and so what we can see is to go from a parallelogram to a rectangle, we have all the same characteristics plus our 90-degree angle for all four of the angles. Okay, if we look over now to our rhombus, by definition, a rhombus is a quadrilateral with four congruent sides. Once again, it adheres to or fulfills the requirements of being a parallelogram because both pairs of opposite sides are congruent. And so, in addition, all four of them are congruent, but that allows us to conclude that a rhombus is also a parallelogram, and so it will share the characteristics of a parallelogram. Both pairs of opposite sides are parallel, all four sides are congruent, the opposite angles are congruent to each other, and the diagonals will bisect. And once again, there are additional characteristics of a rhombus. And again, we are not proving these theorems in this lesson, but they could very easily be proved using triangle congruency. And so we go back and we have two additional theorems that relate to a rhombus. The rhombus diagonal theorem, which says that the diagonals of a rhombus are perpendicular, and the rhombus angle theorem, which says that the diagonal of a rhombus bisects two angles of the rhombus. And so what we have is diagonals which are going to intersect each other at 90 degrees. So we have four 90-degree angles And what we also have is, in addition to angle P equaling angle R, those two angles are bisected, and similarly for angle S and angle Q, the whole of angle S equals the whole of angle Q, and both angle S and angle Q are bisected by the diagonal. Okay, and so now we move to our square, and the square by definition is a quadrilateral with 4 equal sides and 4 equal angles, and this means that by definition a square is a rectangle and a rhombus combined, which means a square has got all of the characteristics of a parallelogram, a rectangle, and a rhombus. And so we will have diagonals that intersect at 90 degrees, 4 congruent sides, both pairs of opposite sides parallel, diagonals that are congruent in length and bisect, and so 4 equal pieces. And lastly, of course, the diagonals would bisect each of the vertex angles, and this would result in 8 45-degree angles as well. Okay, and so what we're going to do very quickly is just jump back and review the true-false statements. And really what the true-false questions are after is to check whether or not you understand the flow, that a rhombus has the characteristics of a parallelogram and more, likewise a rectangle. A square has the characteristics of a rectangle, a rhombus, and a parallelogram, but the reverse is not necessarily true. And so take a moment, pause the video, and go ahead and answer the true-false questions. Okay, and so hopefully you've done that, and we'll just go very quickly over them. And so all rectangles are parallelograms, that's true. All parallelograms are rectangles, that is false. It may be true that a parallelogram is a rectangle, but that is not necessarily the case because it doesn't necessarily have the full 90-degree angles. And so basically this is the logic for answering all of these questions. All rhombuses are parallelograms, true. All parallelograms are rhombuses, false. They don't necessarily have the 4 congruent sides. All squares are parallelograms, this is true. All squares are rectangles, this is also true. And all squares are rhombuses. All of these are true because the squares have all of the characteristics, but the reverse is not necessarily true. Parallelograms are squares, rectangles are squares, rhombuses are squares. All 3 of these statements are false because they're not entirely true. They may be true, but we cannot be sure that they are true. Okay, and so what we're going to do now is jump ahead to the final 3 theorems of the lesson. And so really these could quite easily be proved. What I'll do in this lesson is just explain why the theorems are true instead of doing a formal proof. And so the right parallelogram theorem states that if a single angle of a parallelogram is a right angle, the parallelogram is a rectangle. And so if the given information is that ABCD is a parallelogram, then by definition we have got our both pairs of opposite sides parallel. We also know that opposite angles are congruent to each other. If we are in addition given a right angle, one 90-degree angle, then of course angle C would equal angle A because of opposite angles of a parallelogram being congruent. And then we could use the fact that same side interior angles between parallel lines are supplementary. This would allow us to conclude angle D was 90 and in turn angle B. And so this explains why if a single angle of a parallelogram, not a quadrilateral, a parallelogram is a right angle, then we have a rectangle. Similarly, if 2 consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. And so we know by definition, or sorry, not by definition, but we know from theorem 5.1 that if ABCD is a parallelogram, then both pairs of opposite sides are congruent. If we are in addition given information that consecutive sides, and so I'll pick CD and DA, are congruent, then if we extend our theorem 5.1, both pairs of opposite sides congruent, this means CB must equal DA, and therefore all four sides are congruent, and that allows us to conclude that if we have consecutive sides of a parallelogram congruent, then we have a rhombus. Okay, and the last theorem for the lesson is the hypotenuse midpoint theorem, and the hypotenuse midpoint theorem states that the midpoint of the hypotenuse, remember the hypotenuse is the side opposite the 90-degree angle in a right triangle. If the midpoint of the hypotenuse of a right triangle is equidistant from the three vertices, and so what I'll do is just highlight triangle ABC. Side AC is the hypotenuse. In this case, we have our right angle at angle B, and of course the vertices of the triangle are A, B, and C. Okay, and so what the theorem is stating is that if this point over here, let's call it point M, is the midpoint of the hypotenuse, and so that would mean that CM is equal to MA, then point M would be equidistant from all three of the vertices, so it's quite clearly equidistant M to C, M to A, and then if we look at the property of a rectangle, namely that the diagonals of a rectangle are congruent and bisect each other, then we would be able to conclude, of course, that BM was equal to MD and CM was equal to MA, and if we isolate our triangle, we can see very clearly that what we have is CM equal to MA, which equals MB, and this shows that the hypotenuse midpoint theorem is true. Okay, and so your task at this point is to do two things. First of all, to use theorem 5.15, the one we've just the one I've just explained, to find the measures of angles 1, 2, 3, and 4. In addition to that, go ahead to the constructions page, and what I'd like you to do for this, before you watch the second part of the video, is to write a plan for how it is you would construct a square with a given side AD and a square with a given diagonal AD. These constructions use your prior construction knowledge. You do not need new construction skills. You need only the skills that you should have acquired up until this point. And so the idea is for you to try and figure out how it is that you might construct a square with side AD, write a plan, and then once you've done that for the construction examples and completed the angle example, then watch the second video, which will show you solutions to the angles and also give you a possible approach to constructing the required squares.